Hello. Hi, Carlos.
Hello, how are you doing?
Good. How about you?
Nice.
Hi, Jumbo. Start before giving Carlos the floor. So today we finish the book. So congrats to everybody that made it that far. It's the second book that as a group we read. So it's awesome that we can start and finish things. That's always great. That's always great. It's not everybody that can do that. So yeah, congrats. Today Carlos will take the lead and discussing chapter 10. And the only thing that I wanted to mention is that feel free whenever you have a chance to share on Discord any book that you would like us to cover, to read, and then probably in the next couple of weeks we will like gather all the books and make a poll and as a group discuss. Yeah, that's everything from my side. I'll leave the floor to Carlos so he presents chapter 10. And thanks, Carlos, for taking the lead on this one.
Can I share screen? It's telling me that host disabled
Yes.
participant, blah, blah.
Yeah, go ahead, I guess.
Okay. So there we go. Give me 1 second. Okay, you see the presentation, right? Okay.
Yeah.
Well, as I said before, this is just a shouldn't have to say that, but I use a lot of quotations from the book because Chip makes a lot of good sentences. So every time you see something into quotes in this presentation, it's because it's a sentence from her. So we have been covering a lot of techniques for building applications on top of foundational models. And this chapter is about taking those techniques to basically put them together to make an application. So we will start with the simplest architecture, even if we want to call it an architecture, which is just make it the user talk to a model and have the responses. This is the basic, the simplest possible architecture. And in this chapter, what we are going to be doing is adding things to this schema one by one to build sort of production-ready applications. And one of the things that she was saying about this, about how the chapter is organized, is that we are going to be seeing it in a linear way, but that's just because this is a way that makes easy to understand, because we're going to be adding things one by one, and we always will be adding them to the thing that we saw previously. That's just because it's going to be easier to do it this way. But the things that we are going to be adding, we could start by adding the things that we are going to see in the last step to this first model, to this first architecture. So just keep in mind that even when we are going to be seeing them one by one, it doesn't have to be in this order. This is just because we are going to have the feeling of growing something. And she shows this order because it's kind of natural growth model. This model here has some benefits. I still use it for a lot of applications. Like first, it cannot be simpler, so that's an advantage, of course. And it doesn't need a lot of maintenance, especially if we are using a model that is consumed by an API. If we are using something like OpenAI just with an API key, or even using their chat application, where in that case it's not just a model, it's not that architecture, but it's a very, very simple model, and that is the advantage. But the limitations are basically what drives this chapter, which is It doesn't know about our specific context. The model will answer with what it was trained. It does not have guardrails. The only guardrails, if you want to call it like that, is whatever was on the training. If the model was trained to like be polite, then it will be polite, but that's all of it. Also, one model might not be enough. That's another limitation. In this case, it's not very production ready, especially if we are using an API, because if we lose internet, it wouldn't work. If we get the quota, the limit of our quota, we would also not be able to use the model anymore. So we probably want also to be able to add more than one model. Also might not be efficient because we are also always calling the model and there is no cache. There is nothing making it, nothing implemented to make it faster. So it might not be the best. And also it might be too passive because it's just waiting for us to make questions. And if we wanted to go further, we have to, again, make another question. And even if we go back and we are strict about this model, if we want the model to be aware of the previous questions, we would also have to put them together. So normally we're going to have the first thing that we're going to tackle is context. In the most basic case, it would be just be making the model aware of the conversation, because otherwise it's only aware of the last question. So these are going to be the steps. They are very inspired on what we saw previously on the limitations of this first model. So starting with the context, well, apart from the obvious one, which is build a conversation, we probably want the model to be able to understand the business if we're or the application that it's serving. So the first thing is, before making a question to the model, whatever the user says, we will enrich it and create a little bit more contextualized question to the model. So the most basic case is the models don't even know what day is today. So one very, very simple thing to do with a model, if it's going to be doing things like answering what are the today's sales or something like that, you might need to tell the model what day is today. So we are going to need to provide context. And it can be tools, it can be RAG. Like RAG, we have already said what it is basically have like a database that's going to be queried by similarity or something like that. And then all of that is going to be passed along with the question to the model, so the model can give more specific answers. This architecture is still not very complex. It's just, we just added basically a query by similarity. And then by some sort of prompt engineering, we separated what the user asked and the context that we found in that database, and we fed all of that into the model. So it's what's interesting about this is that what we added was domain specific. What means if we are building a model that's going to answer questions about a company, the services of a company, then to develop something with this architecture means these yellow boxes here are going to be very closely related with what the company does. So it's about building that context. So it's it's not very infrastructure based like the most of the other patterns that we're going to be seeing, but this one is very closely related with the domain of whatever service we're building. And the limitations are also, again, now these are the same limitations as before. We only covered one of them, but still we don't have guardrails. We still have only one model, and so on. So the next thing, it's more or less obviously would be guardrails, because we now can make things like a chatbot that tells you about the services of a company, and even it can tell you the availability of some services or something like that. but still we have nothing preventing that model from doing things that are outside of that service. So one of the risks of not having guardrails is that we can leak private information or execute prompts that, as I said, are compromising, or maybe just outside the scope of what we want the model to do. And to do this, to fix that, the next architecture is basically 3 different pieces. The first one is input guardrails, and with this, what we want is to prevent the entire thing from leaking things like secret keys or something like that. And it's quite easy. Like the first problem here is that either through the enrichment that we did when we constructed context, or just because the user might make a mistake and might include some password in the query, we might not want the model to know that, because sometimes the model is not a piece of our own. Sometimes we are using, let's say, Gemini or OpenAI. And actually, Chip included an example, I believe that from Samsung, or I don't remember what company, a user accidentally submitted private information to one of these models, to OpenAI, I believe. So the guardrail here is something like, where what we would be doing is something like, if we find something like one of our passwords, we would use a dictionary. I believe that from the examples that Chip was showing, she basically suggests using a 2-way dictionary. So you take your password, you change it with a token that it says, this is my password, let's say, something like that, my database password. So that's what you send to the model. And then when the model gives you the answer, it would include the token, because it didn't even see the password. And when you build the answer for the end user, you do the conversion and the other way around. So you would get the password in your output, but it's to the same user that actually submitted the password to you. So that would be an input guardrail. But then we also need some kind of guardrails in the output, because sometimes the problem is not that the user is leaking information, but that the model is either leaking information, which I think is not that common, but it can happen that it's not answering how it's expected. For instance, if it's expected to respond in a JSON format, it might not be doing it. Or if it's expected to answer in a polite way, it might be answering a toxic one. So that's why we need also, after the model, to have some additional checks before we send the output to the user. And also there is this last box, which, as Chip said, is a scoring one. She added this box inside the model because scoring is typically done also by models. But she added it as a different one from generation, because it's typically done by a smaller model. And it's a model that would basically get the answer from the previous model and said something like, probably the model would have some kind of token, of prompt saying something like, score this from a toxicity level point of view from 1 to 10 or something like that. And that way we would have some information about the model, if it's been toxic or not, or maybe other kind of checks. But that's why it's included inside the model API, even if it might be a different model or something like that. And now is when we start seeing that we are probably going to need more than one model. In this case, we are adding the idea of a scoring model, but there are other cases in which we need more than one model for specific, how do I say that? For specialization purposes, because we want to have we have one model that is very good at one task, for instance, coding, and another one which is very good at crafting responses for the user. So we might need somehow a model router, which is a tool that would basically classify the intent of the user. It will get whatever the user is trying to do, and it would just decide it will know the specialist that it has after him in the pipeline, and it would decide just this should go to the coding model, or this should go to the response crafting model or something like that. So that's why this box is also included in the model box here of the diagram. And this can also be used to improve the guardrail capabilities of the model, because now that we have this model router, which is sort of an if or a dispatcher at the top of our chain, one of the things that it can do is to refuse to answer. If the question was already like, give me the passwords of OpenAI, it could just say, okay, let's not even answer, or let's go to a generic answer of the type, I cannot answer you that because I'm not allowed. And that way we could even not spend resources in trying to compute something that we didn't want. Something that it's typically is to use models that are tinier than the big one, because that's precisely the idea of models. They are of routing models, is to try to try to help us reducing computation that we didn't need for that's not going to be actually practical. That's why we are going to be introducing a router in the first step, because otherwise we would just process all in parallel from all the models, but that's expensive. So that's why models, tiny models like the Llama 7 billion parameters are used for these tasks. And in this case, the querying context might need to be readjusted, because we are getting a little bit into an agentic pattern here, in which the second model is going to receive something that the first model probably modified somehow, or just enriched, because it might get not only the query that the user wrote, but also it might get something like the routing model might have said something like, this is going to be given to an expert of development or something like that. So it might change. And another thing that Chip was saying is that the routing can also happen after retrieval. So just to know. And then still into these kind of tools, there is this thing called a gateway, which is sort of similar, but a little bit different than model router. In this case, the model gateway, what it does for us is basically we can put into a single box several models. So we treat them as if it was only one. And this is especially practical for when we want to switch from an OpenAI to a Google model. If we use a model gateway, we would send the request in one specific format, and to change from one model to another would be just a matter of changing the configuration, which is pretty practical. So that completes this next box of the gateway. This means that we have now more than one model in our system. What means that we can have we can use them in different senses. We have been talking about using them for specialized things, by letting the router decide which of the models is the one that knows how to handle better a certain query. But we can also use them as fallbacks, because as they are under a gateway, means they all work in the same way. So that means that we can, in case one of the APIs is down, we can just disable it through configuration and have the entire system work with a different one. So we have a little bit more of resilience. And also this system serves as an access control, because we can, in combination with the router, we can now decide that if one of the models that we are including in our application is more expensive than another one, maybe we can default to one of the cheap models and only include the other ones when it's convenient. So we can use it as a strategy to reduce costs. And also it makes easy to monitor models, the access to the different models, because again, if we have only one interface for all of the models, then it's easy to add a logging for every input and output or a monitor, and it's going to be simpler because it's only one way to talk to the model. And now we are starting to deal with a complex network. If we go again, before we add more things here in the model gateway, we have already possibly 3 or more models, because if we have a routing, the generation box might have more than one model. So from the query to the answer, we now have a lot of pieces. The context enrichment is going to increase the latency a little bit. The input guardrails are going to increase it even a little bit more. The model gateway definitely would be the biggest latency cost here. But then we also have the guardrail. So now we start probably needing to add something to fix that. And the first idea is to use a caching system. And for that, we have to talk about 2 different caching strategies. The first one is the most obvious one, which is exact caching, which is appealing, especially when we are going to have steps of multiple retrieval processes. Like, for instance, in this case, we are already, as I said before, we are adding pieces linearly, but we don't need to do that linearly. Maybe this was just from the first model, from the first architecture, where we only have the user making queries to the model. In that case, it's not going to be that interesting. But now that we have multiple pieces in the network, the queries are more expensive. So adding a caching system that is typically memory stored, like Redis or something like that, now is going to be like clear benefit. If we introduce such a system, then we are going to have to introduce some sort of what's called an eviction policy, which is we have to decide what we do with the caching system. Are we going to store things forever? Are we going to remove the things when they are old? Are we going to remove them when they are not used? So we have to decide in something like that. And also we have to be very careful, because if we are caching things, especially in environments where users, maybe that context that we were talking at the beginning is not the same context for all of the users. Maybe we have an application that serves, is a chatbot for all of the members of a company, and it would be aware of what user is doing the query. So maybe if the user is an administration user, then the context is going to be enriched with some information that other users shouldn't see. So in the same way that we would protect that, we also have to be careful that the things that we store in that Redis cache have to be either aware of who is making the question, or we should only catch things that everyone would be allowed to see, because otherwise maybe something would be cached because it was asked by an administrator, and then a user who is not an administrator would do the same question and receive the answer. When that is something that we have to be careful about. And the question about this is that this all works if we are doing exact caching, what means the question of the user was stored and we are using it as an input, and now we are treating all of the network, all of the architecture as of our application that creates an output, and that's what we would be catching. But the issue is that the cached answers we would be only using them if the user created an input that was exactly like the previous one. So some strategies to get around this is semantic caching, for instance, which is something similar to we would use a vector search that is similar to the one that we use when we do RAG for searching context and enriching the user queries. So in this case, it's what's being suggested is to do the same thing, but to retrieve the question. So if someone put in with a very naive example, if someone asks what's the capital of Spain or what is the capital city of Spain, semantically the answer is the same. So we could be able to reuse a lot of the cached responses. So now we have something that looks more or less like this. We have sometimes the query of the user is going to be found either exactly or semantically, and we would be able to skip all of the architecture and just give the response, which is going to be probably saving us a lot of computation. And here is where we start doing the most interesting and also costly computationally thing, which is to start adding agent patterns, because the idea here is that we are going to give questions to the system as we did before, but in this case, instead of passing it once through all of the architecture, we are going to do that, but we're going to tell the system, be aware of, try to evaluate if you actually solve the problem when you do complete an iteration. And if not, if you think that this is not the full answer, then just enrich the context and try again, do another round. So we're going to have something that's difficult to see, but now we have this yellow line that before this, we were just getting the output guardrail, and that was going to the user. In this case, that is where we might create a loop. And that loop, obviously, we have to do that with caution. In tools like small agents or things like that, we basically give it an integer, which is the number of steps, because otherwise this can very easily create infinite loops. Because the problem, if we ask a question that the model, the entire network does not know how to solve, then the last step is going to connect it with the beginning, and that can create an infinite loop. So we have to be careful with that and probably set just a maximum number of trials. And the last piece that we're going to be adding to this architecture is basically try to give memory to the system. And this obviously has to be done with a lot of care. It's something for the same reasons as the cache, because every time we let the model modify something or have how is it called? Secondary, now I don't get the word, have consequences. The problem is that those changes might affect other users. So when we add memory or something like that, we have to be really careful, because it's a way that it's the first thing that a hacker or someone with malicious intentions is the first thing that you would try to manipulate. Because if I know that I can change the answers that the system gives to other users, then I could use it in my favor, because I can manipulate your system to, let's say, do ads for me or something like that. So we have to be careful with that. But having said that, if we do that with care, this is the memory of the system. This is where we would add something like the system being aware of the entire conversation, or even being aware of what the user has been saying in previous conversation, or if we want this to be an agent that actually performs, let's say, reservations in the agenda of someone, then those reservations would go here. So now we have a pretty complete agentic system with more than one model, with a rich context, with guardrails in the inputs and in the outputs with caching for latency. And now we have all of these pieces. The thing is, this is complex. So now we start needing to have a good monetization and observability system. Here, what we want to do is basically mitigate risks and discover opportunities. Mitigate risks because obviously we want to see if someone is trying to misuse the system, or if there is a piece that is not efficient and is costing us more than it should. We want to detect it as soon as possible. Discover opportunities also because we know that we have now, we should now have something like caching system in place. So now we should be able, with this monitoring and all of that, we should be able to discover possible things that should be cached because maybe they were not included by default in our caching system. But now if we have all of that in place and with the monitoring, we could discover that very tiny changes would cause big advantages because we now have a very complex architecture. Having said this, Chip differentiated in the book between observability and monitoring by saying that monitoring is typically making research in our logs. But that's like looking at the system from the outside, is what the system is doing. But we probably want to get inside and see what piece from inside the model was causing a certain output, a certain behavior. So that's basically the idea. We're going to be monitoring, but also going to we want to see what on the inside of the model caused a certain problem. So that takes us to start talking about metrics. Some of them we already mentioned in the previous chapters. In this case, these are metrics related with when something happens in general, like mean time to detection is, well, when errors happen, how much time does it takes us to realize that it happened something. Mean time to response is obviously going to be a bigger time because it's from that detection, how much time did it take us to actually fix it. And then some interesting one that I actually didn't know about is change failure rate, which is we should be aware of the changes that we are introducing in the system. Every time we deploy something to production, we should have that into our metrics so that we can measure the number of failures that our system has, so that we can calculate this rate and say, okay, this last change caused more issues than the previous one. Especially important if let's say that the periods are comparable, like imagining that we are deploying every month, then we should have more or less the same number of failures this month that the month before. If we have more, then it means that we introduce more risky code probably, or more risky changes than in the previous iteration. This obviously takes us to the idea of evaluation, which is that when we have any kind of issue that we find in our models, we should use it to evaluate what we are doing. And basically, means that the monitoring should trigger changes in the pipeline so that we actually decide that something that we did was not the way to do something. This I actually already mentioned it. It's basically the idea that observability is going, is like an inside, it's a monitoring that goes inside what the model is actually doing. And now that we're talking about monitoring and metrics, one of the things is that when we're going to have a lot of metrics in our system, it's a complex system, and as we are going to be seeing from now on, when we are going to be talking about a lot of possible metrics. One of the important things about metrics is that they should serve to a purpose. Like if we are calculating how often a model is generating invalid JSON, is because we are going to use that to try to fix that and try to minimize this, because we want the model to generate less invalid JSON. So in the same way, another metric that can serve to a purpose is how often users are stopping the generation halfway, because that means that the model is having very likely a big latency, or that even from the beginning is generating responses that the users don't like. Or even what's the average number of turns per conversation, because if we have now an agentic model where all of the architecture can be iterated more than once per query, it means that if it iterates many times, it means the user is going to have to wait a lot of time. So also, these are all metrics that are telling us that for each of them, we're going to probably want to do some change to the pipeline, to the entire system. And now we're going to be talking about different kind of metrics that we could be looking at. One of them is length-related metrics, which is either the user writing very big inputs, input context, or maybe the model being the one that is generating a lot of text. And with these metrics, there is something they have something which is they are very difficult to interpret, because the user might be writing a bigger context because they know now how to do that and use that in their advantage. So maybe before they were doing a query and waiting for the response and then adding something, but now maybe they are using one bigger query rather than many multiple tiny queries. So we have to, before deciding if it's good or bad, we should make the metrics trigger questions on us. So they are not. One interesting insight from Chip here in this section is that metrics are not necessarily giving us answers, although they are information, but they might trigger questions on us so that we go and try to answer them. Then there are other questions that we saw in previous chapters already, but just as a refresh, the latency related metrics, like how much time does it take to the model to generate the first token, or the average time per token, or even the latency. The latency, now that we have a system with more than one model and even more than one iteration through the whole architecture, the latency becomes something that we really want to monitor. Then there are queries that are very closely related with the length related metrics, which is the cost ones, because sometimes even the context could cost us some money, but obviously the number of queries, if we are having again a system that is agentic and that processes multiple times one query, that means that one user query can trigger multiple model queries, because we could iterate, and that if the model is let's say OpenAI model that we are using through API, that can cost money, so we have to monitor that. Obviously, not only the number of queries, but the volume in number of tokens, both of the input and output, because again, that can be related with the cost, the literally money that we have to pay for making the system work. And then also the tokens per second, because we might be using GPUs on our own, so we are paying for minute of usage. So we also want to keep track of that. And one great thing about all of this is now we know a lot of things that we want to monitor in our system, a lot of metrics that we are going to be gathering, but we don't only want to have like a metric that is the average time to or the number of tokens or average time to an answer, but also we want to have information that allows us to broken that into things like what was the user, let's monitor a particular user, or let's monitor what happened with different versions. We have been releasing different versions of this architecture. So which ones are causing the latency to be bigger or tinier? So this idea of being able to break down metrics into different relevant axes, and basically being able to do analytics on the metrics, I believe that is the real deal here, because otherwise we're going to have either just numbers, that is the average time to response, but that doesn't help us doing what we were talking at the beginning, which is be able to track down what caused a certain problem, which is what we want if we are maintaining the architecture, and we want to be able to feed and evaluate and fix the pipeline. And one way to do that, to achieve this, is by using logs. So the idea here is try to log all of the metrics that we were talking before. And if we were talking about metrics, which is metrics where somehow state concrete measurements of the state of the system or of the state of a petition, of one of the petitions, the logs are going to be giving us how those metrics have been evolving over time. So is the way that we are going to be able to implement those analytic systems where we are going to be able to have all of those dimensions. So that means when we add a line to the log, we should think if I'm going to need, if I want to have the access of the release, so I can break it down by release version, then every time I add a line to the log, I should add the release tag, so I can then later use that to build an access of insights. And one of the keys that Chip said about logging is you don't know what you're going to need in advance. So basically log everything, and that is going to allow you to then build a smart system. And to finish with this monitoring and observation part, basically the idea is to consider what things can cause changes in the metrics. One of the things is we're going to be, if we're designing this agentic architecture, then there are going to be prompts inside, like the prompts that tells the system how it should behave, or if it should plan before it does things or not. So all of those changes in the prompts are going to change, are going to have an impact in the corresponding metrics. They can make it more efficient but slower, or things like that. So that is one of the things that we want to include in those logs so that we can analyze the system. Then user behavior changes. I believe when I read this, I believe this is probably the trickiest one. If our users are getting to know our system better, then they might be using it in a more appropriate way. So they might be changing the way they use the system. That can also cause changes in the metrics. They might use longer prompts, or maybe all the contrary. Maybe they realize that it doesn't worth making very long questions, because maybe they realize that sometimes shorter questions gave them also the good answer. So all of these things can have an impact in the metrics. And obviously underlying model changes. Again, we are talking about some architecture where we are going to have several models, probably, and some of them are going to not be in our control. Probably we're going to be using some models via API, and OpenAI, for instance, might change their models without telling us anything. So maybe they make a change that makes the things go slower. and we might not know that even without a change in the API. We might not change anything, but these are things that, especially when we are relying on third party, can make monitoring tricky. So now we're going to get to the last part, which is about orchestration. This is about basically trying to make all of the things work together. And it consists in basically two things, component definition and chaining. Typically, these tools are now going to an approach of a node-based system where nodes are the things, the components. So they are the points in a network. And then chaining is the edges of the network, the connection between one nodes and the other ones. So one of the suggestions that Chip does is if you need to improve the latency of your system, then try to parallelize stuff. Obviously, if you can make a question to several models, if you can afford it, and then take the quickest response, you have something that would make the system faster. For this type of orchestrations, we have a lot of open source alternatives. Actually, these are the ones mentioned in the book. And in the book, there are the links. Actually, they are all links to GitHub. So there's no excuse to use one of these applications. They are pretty mature and all of them open source. So and now what to evaluate when we are choosing what platform, which of these ones we are going to be using or something like that. Well, one of the first things is integration and extensibility. So the first thing is, does it cover the models that I want to use? Either if they are local models or third-party modules, not only the models, but also other parts. We are going to be, we have been talking about enriching context. So does it support easily vector databases, for instance, or things like that, or caching system? Does it support integration with Redis, or all of these things that we have been talking about? Because it's going to make your life easier if you can put all together into only one single tool. Also, if it has support, and what type of support does it has for complex pipelines? Because we are, again, if we were only talking about the user querying a model, we wouldn't even need a pipeline in the first place. So the idea is, how does it behave when things start to grow, when the code base starts being very big? And I think that one of the most important things about these tools is that if something fails, how easy it is to spot what failed. Like, there are going to be many parts when one of the queries of the user is submitted. It's going to pass through a lot of steps. So we want to know if there is an issue. We want to know which one was what part was the one that was introducing problems. If there was something enriching the context, or it was the model router, the one that didn't submit the query to the right specialist model, or whatever happened. So all of that logging system is going to happen inside the pipeline. So that's important to consider. And of course, ease of use, performance, scalability, all of that is basically telling us that if you're going to rely the orchestration to one tool, then that tool is very important to work properly. And now one of the things about all of this is, okay, we want to have a lot of metrics. We want to have a lot of information. Sorry, 1 second. We want to have a lot of information about our system, but how do we get all of that information? Some of it we've been talking about it, and it's kind of obvious, like latency time. We know how to measure it, but something that we are really probably going to have to prioritize is if the user is liking the use of the application. So this last parts is about how to gather information from the user directly. And one of the most obvious things is the application itself that we are presenting to the user should be gathering information. That's the main idea of this whole section. If we add a button to cancel, that we mentioned it already, if we have a submit button that can stop the generation in the middle, we should track that. If we have generating a start button to generate, we should track when it's pressed, and we should track when it finishes generating context. So basically what we're going to see from now to the end of the presentation is that we should be trying to track every part of the application and try to make all of it work like an application for the user. The user shouldn't have to be thinking, we shouldn't have to think our application or the gathering feedback from the user as a layer that we are going to add in the top of the application, but as the application itself. So one of the things is that we are seeing in almost every chatbot today is whenever we submit a question, we have a thumbs up, thumbs down button. That is there for a reason, because that's going to give us pretty interesting insights about, for instance, how to retrain the model for next generations if the model is a model that we train on our own. So in the future, we are going to be able to take the query of the user, and then the ones that were thumbs up, we're going to be able to feed the system and tell it, try to give us more answers like this one. And if it was thumbs down, obviously not. And then there is also implicit questions, like if we are talking about, for instance, Copilot or something like that, when it suggests some code, if you click escape and you reject that, that should be considered also as something that you can include as a metric, because it's also telling you that the user probably didn't like that suggestion. So you should kind of monitor that too. This creates opportunities. For instance, every time that we offer some choices to the user and the user chooses one of them, you have not only a way to decide which query was best, but also to profile the user a little bit, which might be something that you want to do. And also, another way to get implicit metrics is whenever the user continues a conversation saying some clarification, like, no, that's not what I meant, that's not correct, that's not factual, or that does not came from the sources that I gave you. All of that is an opportunity for also getting a metric and improving the system, in this case for error correction. Another thing is the regenerate button. Wherever we have a button to generate another answer or a variant of an answer, it means also the user did not like, very likely did not like that generated first response. So this is another thing that we could probably want to add as a metric. And this one, I didn't see this one coming, but it's actually quite interesting. When you have now almost every tool, every chatbot has also this possibility of storing chats, entire chats, and you can give them a title, which typically has a title that is generated by the user itself, but sorry, not by the user, but by the system itself. So all of the operations that consist on the user either deleting one of the chats or moving it or changing its title, all of those are opportunities to monitor something and to improve something. If the user is deleting a conversation, it probably means that it was not very useful for them. If we have a sharing option and it's being shared, then it probably means that it was a good one. And if the user is renaming it, it probably means that it wants to store it. So the conversation was good, but probably the title wasn't. So all of those are things that we can use to then, in a later iteration of our architecture, improve things. And this is what we have been doing now, is start to think how to gather feedback. Now it's not, we have been talking already about a lot of metrics that we can have. The idea now is rethink how we get feedback. So the idea, as I said, I suggested before, is to try to include the whole user journey in what we are trying to monitor. So that every single decision of the user, if it can be telling us something about whether the user liked or not what we gave them, we actually monitor and can then take decisions on it. So the idea is, one of them is give the user options, whenever options to tell us if they liked or not something. That is especially important for errors, like if you can add a button saying I did not like this, or something like that, then do that. Another way is, as we said, just a regenerate answer is already telling us the user did not like the answer. And actually is very transparent for the user, and is very useful because the user is not going to be thinking I am tagging this answer as bad. The user is going to be thinking I'm generating a new answer, which is what I want. But now we know that the previous answer was not the best, probably. Also, even if the model, some principle that is also interesting is that even if the model fails, even if it does not complete the task that it was meant to complete, the user should be able to complete it. And to put an example of this is, if we are telling the system, let's say that we are using a system that is connected with MCP that can administer my computer, and I'm telling the system, hey, tell me what files I could remove. Then if the system does not detect a file correctly, it detects a file that should not be removed. What we should do is the UI to be something like a suggestion, like here's a checkbox with all your files, and you have pre-selected the things that the model thinks that should be selected, but now the user is the one that can select or deselect. So from the perspective of the user, it's like he's in control, or the system is not making any mistake, and he does not have to go back and make the question again and copy the entire output, but changing the files that he does not want to delete. But it's more like, even if it's giving us feedback, again, as we said before, but it does not look like he's giving us feedback. And another thing is, if the model has low confidence, that's another opportunity to get user feedback. Like if you don't have too much confidence, then maybe something you could do is generate a second answer and give the user both options. So the user can tell you, I prefer this one. So that's what we were saying, that it should integrate into what the user does. Some examples, when Midjourney generates images for you, it generates, let's say a batch of images. So it gives you 4 images. That's already in the line of what we were saying before, because it's giving us options. And now what it's going to tell us is, what do you want to do with each of them? You want to upscale an image? Or do you want to generate a variant of each of those images, or you want to generate the entire batch? So that's a very clear example of the type of UI that is generating a feedback from the user. Because if the user upscales one of the images, then it's probably that image that is preferred by the user. If the user regenerates the batch, then probably the entire batch wasn't that good. So that's sort of the idea. And then the example of Copilot, which I mentioned already, if we when Copilot autocompletes, it normally gives you 2 chances, either accept or reject. So that's another feedback chance. If something is accepted, it was probably correct, or it was probably a good answer. And if it was rejected, it was probably not. And some considerations is, one of them is don't force the user to make a choice. So add, if possible, add something like, I don't know. Don't just tell him, what do you want? What of these two alternatives is better? Chip added here as an example that she was, I don't know if it was via OpenAI, but she asked a question that it was about statistics, and she got two answers that she didn't know how to evaluate, but she was being asked, which one do you prefer? And she was like, I don't know. And she didn't have an option. So basically, we are adding things to get feedback from the user, but let's try to make it voluntary and not force the user to tell us things when the user does not know. And also be mindful on whether you make that public or not. I would say prefer private and use public whenever it makes sense to make it public for transparency or something like that. But one of the examples that is given here is when X made the like button private in Twitter, in X. Apparently the number of likes increased a lot. And that's basically because the people wasn't feeling like observed. So now I click whenever I like something. Before I clicked, I like not only when I like something, but also when I thought that I was not going to be judged for liking it or something like that. And when we get here now, some extra final considerations now is about, okay, we have a lot of feedback, but feedback has its limitations also. One of them is the biases of the user. For instance, the first one, the user is typically going to be trying to be positive. So one of the typical things here is when you make questions and provide ratings from 1 to 5, people's gonna think that something lower than 5 means that there is a problem. So the answers are gonna be biased towards either 4 or 5, because 4 is not gonna mean almost perfect. It's gonna mean there is an issue. So that is something to take into account. Randomness, this is very related with what we were saying before. If you provide the user with a feedback choice, but you force them to choose, and the user does not know how to choose, or it's just you just provide them a memo text where they have to write a lot, they might not have the motivation to do that. So they might either say something random or not care about giving us feedback. So that would make the feedback less interesting. The position bias is basically the idea that if you are given two options, you're probably going to prefer the first one. So that is also to take into account. And finally, one consideration about feedbacks is that feedbacks, if we create loops, they might degenerate. That means that if we have a system that is recommending films, and we take some films that are recommended because they were very, very well ranked in previous iterations, then we are going to show them at the top. And that is going to cause them to have even better votes. So we are going to increase the possibility of us recommending those ones and decrease the possibility of recommending other ones. So basically, the system can exaggerate some of the features that actually might be there, but we might be exaggerating if we create loops and do the process more than once. So in summary, we have seen how to build applications on top of foundation model with all of the techniques that we saw in the previous chapters. We saw how to add context for making the architecture aware of the specifics of our application, of our company, or whatever problem we were trying to solve. We saw how to add guardrails in the input and in the output in order to make it safe and to try to avoid leaking passwords or private information. We saw how to add model router and model gateways, basically to be able to have models that are specialists in some tasks, and also to be able to manage more than one model at once. Also how to add cache to the system so that basically we improve latency without changing that much how it behaves from the user's perspective. And finally, how to add agentic patterns so that it can keep working on something until it gets to a successful response to a problem. We saw that with all of these, we are creating more complexity. So we started talking about monitoring and observability and all of those crucial things that we have to do to have information about whether the model is working or not. We talk a lot about metrics, both generated by the user and also more system-related metrics. And finally, we saw how to rethink the interface of the application so that it's generating feedback from the user, but not as a layer that we add on top of the application, but every single part of the application itself has been thought so that it actually gives us information on whether it's doing the job that we wanted or not. And that's it. I finished with a word that's from the epilogue. I just changed the you made it from we, because we did it all together, but we made it. We just finished a technical book with more than 150,000 words, 160 illustrations, 250 footnotes, and 975 reference links. So good job. And that's it. We finished it.
Nice. Good job, everybody. Indeed. Thanks, Carlos. That was an amazing presentation. Thanks a lot. I see that Jambo made a question. I don't know if you can see it in the chat. It says it's a question regarding step 5. I don't know if you have an answer.
I want to confirm that step 5 add agent patterns reflect the overall design approach, including methods, React to former. Yeah, I guess, yeah. I believe that Chip basically made a summary here and tried to simplify by saying that we just create loops where the system can keep working on it. But that's basically the idea, I guess, to actually start by trying to make a plan. Then if there are multiple steps, try to execute the first one and all of that. So I guess that the answer is yes.
Next. Anybody else has a question or comment? Okay. Then thanks again, Carlos. I just wanted to say a reminder that if you have any ideas about any book that you would like to read in the next following weeks or probably month, because at least from my side, I will be at the company trip the whole month, so I cannot join any other calls. But perhaps we can give like a rest of a month and then start a new book. But feel free to send it on Discord, and we'll collect all the books that we want to read, make a poll, and then decide and start probably around June, end of June, something new.
Yeah, maybe we can start with the list that we had already when we chose the cheap one, because there were other books, so we can start with that and try to add the other.
Indeed, that's a great idea.
Can I add one more, Carlos? And brilliant presentation, Carlos. Thank you so much for giving everything to sort of wrap it all up as a capstone. But a really quick point, I know we had a list. We had a list before, but the pace of AI development is so rapid. There are new agentic frameworks. So we've started with how to build a model, to how do you do the AI engineering, but now how do you enable capabilities? This is one thing that I've noticed personally, that a lot of technical data scientists and so on don't really focus on the deployment, the development deployment of actual capabilities within organizations. This is the stuff where when they say AI is going to change the way we work, actually working and doing that. So the areas, the entities that are actually doing that are companies not like OpenAI, although they're building the core models that are being consumed by the enterprise platforms like ServiceNow, Salesforce, and many others. If you look at the keynote from the CEO of ServiceNow earlier this week, if you go to servicenow.com, you'll see it from their Knowledge 2025 conference. Bill McDermott is a salesman, extraordinaire. But he even brought in Jensen Huang to support his contention that an entity like ServiceNow is completely changing the way organizations and enterprises, large governments to all of their customers, the way they work. So would it be useful, and I would ask everyone to also consider frameworks, methods, books, technical tools for us to approach with a class like this over a concentrated period of time, 5 weeks, 10 weeks, on one of those frameworks as well. So just please do keep that in mind when you make some recommendations, as opposed to just a one-off. That's all I wanted to say.
Yeah, if you have, Masha, if you have any like specific resources, yeah, send them over as well.
Of course.
It's great.
And we can have a dialogue on it.
Yeah.
Ideally.
Nice. Awesome. Yeah. Anything else before we leave? I just want to say also thank you for this. We finished the book at the end. I think the plan was 10 weeks. We made it in 11 weeks. Not so bad, actually. So yeah, thanks everybody for joining. And yeah, congrats as well.
Yeah, so just for the recap, we might do a pause of around 1 month, and maybe in 1 month gather to basically whatever we said in the chat, whatever we suggest in the chat, we discuss and we decide what to do next.
Indeed. Yes.
Sounds good.
I'll send also a message on Discord just so everybody is aware of. So next week there won't be any. At least the next 4 weeks there won't be any calls. Of course, if you like, you're also welcome to organize something unofficially if you want, if you just want to chat. But yeah, official calls there won't be. All right. See you. Have a great rest of your day. Enjoy.
You too.
You too.
Thank you.
And
very much.
happy Mother's Day to all moms on the call.
Happy Mother's Day as well.